So we're talking about transformations. And this is pretty fun. First year I've taught it. It used to be a 7th grade thing that we taught. Now we put it in with the algebra. However, I tutor it all the time because I tutor quite a few geometry students. So I'm just excited to bring it into class, get a little more formal with it. So a transformation is a change in 3 things. It's a change in, or it can be, position, size, or shape. You've got it on the packet, yep. So a transformation is a change in position, size, or shape. So we're taking a shape and we're changing it. It's pretty much what a transformation is, okay? In particular, we're talking about translations today. All right? A translation is a transformation that moves each point the same distance and direction. Some people that maybe don't have as much of a vernacular as you do might call it a slide. But we fancy. So, we say translation. Now, this is also called a translation fits within this thing. It's called rigid movement. And so the reason it's called a rigid movement is because your figure in a translation is always congruent. It means what you end up with is the same exact size and shape. It's just in a different spot. Okay? Congruent is going to mean it has the same angles, the same side lengths. Okay? Not to be confused with similar. Similar figures would have proportional sides, kind of like if you had a little triangle on your iPhone and then you zoom in. It's the same triangle, only bigger. Those would be similar. When we're doing translations, the image is going to be exactly the same, just somewhere else. Okay? Let's see what I mean. Kind of like if you were to translate a language, you're saying the exact same thing, just in a different way, right? Okay. So, also what you need to know. And I ran out of room on this page, so we're going to write it in this cloud. Okay? Also, the new thing that you make is called the image. Okay? And what's kind of confusing is your original is called the preimage. The preimage is the original thing, right? Because the original comes before. So the new thing is called the image. The original, if you hear me talk about it, it's called preimage. All right? Cool. So we took care of the vernacular. Let's take a look at example 1 here. Also, when you see those little apostrophes, the word we're going to use in math for it is prime. When you get really efficient using it, maybe you've optimized the things you've done, then you can be Optimus Prime. That was a bad joke. Sorry about that. Okay. So, when it has the apostrophe, the prime, that means that's the image. That's the new thing. All right? So check this out. We have coordinates of A, B, and C on our graph, and this is telling us it wants us to go 1 right and 4 up. So we can count that. We start at, let's do A. 1 to the right, 4 up. That's that spot. That's A prime. I'm going to do that in a different color so it pops. You want it to pop? 1 right, 4 up. 1, 2, 3, 4. That's A prime. Okay, let's go B. 1 right, 4 up. That's B prime. C. 1 right, 4 up. Nope, did something wrong. 1, 2, 3. There it is. C prime. Then I gotta try to draw straight lines on here. Let's see if I can do it. Oh yeah. Pretty good. So, there's my image. So, image, preimage. All right? And so then I need coordinates. So, A prime has a coordinate of 2, 1. Guys, make sure your coordinates are going in parentheses. Otherwise, I'm going to get you for a half point. B. Why am I going to get you for a half point for no parentheses, by the way? Titus. Yeah, math is communication. All right, so B prime is 4, 4. And C prime is 4, -2. So those are my new coordinates, right? This is my favorite part of this down here. And this is called... Oh, I don't know why I said negative 2. It's 4-2. Sorry, 5-2. How did I get all messed up? Oh, I just went to regular C. Thanks, guys, for saying something. C prime is 4-2. No, 5-2. I wrote down the coordinates for the preimage. All right. So here's a rule. What's happening to my x value each time?
It's adding something. It's subtracting.
By how much? 1. So my rule is going to be x plus 1. And the reason you're adding 1 is 1 to the right would be an x value increase on your coordinate plane of 1. Okay, what's happening to my y value? Going 4 up, y plus 4. So on my y values, you notice, plus 4, plus 4, plus 4. So this right here is called writing the rule. And it's saying I have an image xy, or I have a preimage xy, my image is going to look this different. I actually, myself, I really like starting with the rule, and then I just do the computation versus counting. It seems to be faster. I can just add 1 and add 4 way faster than I can count 1 right and 4 up, and then I'll just plot my image. All right? Okay, next page in the notes. So example 2. The first thing we need to do is write our preimage JKL. So J is 02, 02. K is 34. J, K. And L is 51. The L is also what the 8th graders are going to take when they play me in basketball in about a month, okay? Not 2 months. And guys, here's what I'm going to do. Here, it tells us right here what the translation is. I'm going to jump to the rule next. Oh, I got to draw my lines in. Nice lines. I'm going to try to draw nice straight ones. Oh, yeah. Those are real straight. Okay. So I'm going to jump down to the rule. So if it tells us to go 4 left and 5 up, what's happening to our x to go 4 left?
Plus 4.
Minus 4. And then 5 up, what's happening to my y? Adding 5. So you see, that's some of that expression work we had worked with earlier in the year. And the reason I'm going to do this is I'm just going to subtract 4 from my x, add 5 to my y, and I'm going to get new points because it's going to be way faster than counting. So for my j prime, 0 minus 4 is negative 4, and 2 plus 5 is 7. For k prime, 3 minus 4 is negative 1, 4 plus 5 is 9. And for L prime, 5 minus 4 is 1, and 1 plus 5 is 6. I just think you're going to do this anyway, right? Way faster just to plot the points than count. So I'm going to go different color here. Let's go with the purple. So negative 4, 7 is my first point. That's J prime. K prime is negative 1, 9. K prime. And L prime is 1, 6. L prime. So is this new triangle congruent or similar? Congruent means the same exact thing. Yeah, congruent. So it's congruent, and we know that because it's exact same size and shape. Okay? If it was similar, it'd look like the same triangle, just bigger or smaller. Right? I like to think of the pinch. You guys know what I mean by pinch zoom? Yeah. On a screen? Okay. That's what so those would make similar. We're going to skip. I don't understand why there's that little thing on the notes under there, so I'm not using it. We're going to jump to example 3. Anybody need more time on this page?
Wait, what are we skipping? The chart?
Yeah, we don't need it for anything. So example 3. I want you guys to talk at your table and come up with the rule, please. All right, guys, who's got a rule for me? Jack. What's happening to x?
X plus 6
Okay, and y?
plus 2.
Yeah, let's check it out. 6 right, 2 up. 6 right, 2 up. 6 right, 2 up. Let's go. Okay. So that's how you write the rule. Okay? Cool. All right, example 4. Let's graph these points. We got 0, 3. That's T. We got 2, 4. That's u. Not you, it's you. And then v is 5, negative 1.
It's you.
Let's draw some nice straight lines on here. I'll do my best. Okay. So TUV, there's our triangle. Now, we need to translate it. Who can describe that translation in words for me? James.
X?
No, in words. What is it meaning? Where am I going?
Yeah, that's what I'm going to say.
Okay, what's happening to X?
It's going 3 to the left, and Y is going down 1.
So 3 left, 1 down. Cool. So one thing I like to do is, it says draw the image. Okay, next, I don't know if I like this. Sometimes I like to just draw the points or do the math to get the points, but I guess I'll go with this. Let's just draw the image. Let's go red. So I'm going to go 3 left, 1 down on everything. So 1, 2, 3 left, 1 down for T prime. 3 left, 1 down for U prime. And 3 left, 1 down for V prime. So there's my image. Now here's what's going to get crazy in a minute, man. It's about to get real crazy. So I get points for T, negative 3, 2. My U coordinates are negative 1, 3. And my V prime coordinates are 2, negative 2. Anybody else think battleship the whole time they're working on a coordinate plane? So that's what I do, man. You guys know that game I'm talking about? You can't see the other person's ships.
I played it.
That's a good game.
I put it on my.
We had to do math.
All right, so now, guys, check this out. We got some double primes now. Double prime. Because we're taking our image and making a new image from our image. So this translation is not happening from our original. It's not happening from our preimage. It's happening from our image. So now I'm going to take these 3 points, and I'm going to perform the rule. And this one I'm going to choose to get my ordered pairs and then plot them. Just show you another way. So I'm adding 3 to my x, taking 3 away from my y. So adding 3 to my x, I'm going to get 0, 2, and 5. Subtracting 3 from my y, I'm going to get negative 1, 0, negative 5. So do you just see how you can do that math pretty easy versus counting on your coordinate plane? So this was my original. This is my image. This is my image from my image. Yeah.
Why are you subtracting 3 from y?
Because right here, the rule it gave me says, yep, good question. So this is going to be my new image. 0, negative 1, which is T double prime. U is 2, 0. U double prime. And V double prime is 5, negative 5. Negative 2 minus 3 is negative 5. And then when you're done, should your triangle be congruent or similar? So, it is still congruent, right? It's the same exact triangle in a new place. And here's what we're going to do. We're going to do something crazy. I didn't even do this with first hour, guys. We're going to write a rule to go from the preimage to the image of the image. We're going to go to the double prime image, all right? So, what's happening to the x value to get to the blue one from the preimage? So to go from here to here, what's happening to the x value? Nothing. So I'm just going to write x. And then what's happening to the y value? Minus 4. I think it's minus 4. 1, 2, 3, 4. Minus 4. 1, 2, 3, 4. So what's cool is I could have gone from my original to the new by just doing x minus 4. But instead, we went 3 left, 1 down, and then we went 3 right, which undid the 3 left, and then 3 down. So you can write a rule from the original to the third as well. I'm just showing you.